now that we've got a feeling about how end behavior and the roots of polynomials work, we're going to use all that information to help us sketch the graphs of polynomials. So we're going to consider polynomial expressions when they're in factored form, as factored as they can be. We're going to determine what the factors of the polynomial tell us about the actual graph. And then we're going to use our understanding to sketch the graph of an example polynomial. Maybe two. Alright, so let's look at our old friend f of x equals x squared minus 5x plus 6. I say old friend, what I really mean is that we understand quadratic functions pretty well, so we know what this graph looks like, and so we're going to use our understanding of this one to understand some of the other ones. So first thing I want to look is where the function is equal to 0, and we know exactly how to do that. We got a couple of techniques actually. We could use the quadratic formula if you wanted to. This one I'm just going to go ahead and factor that. It factors nicely to x minus 2 times x minus 3. That means we have to have x minus 2 equals 0 or x minus 3 equals 0. So our two possibilities are x equals 2 and x equals 3. Now, what does f of x equals 0 tell us about the graph? Well, f of x equals 0 means that our y-coordinate is equal to 0. And if our y-coordinate is equal to 0, that tells us we're on the x-axis, which means that those tell us where the x-intercepts are for the function. So remember, for that one, we have our places where f of x equals 0 at x equals 2 and x equals 3. So we get a graph looking like this. Now we know it has this shape because it opens up. It's a quadratic function where the leading coefficient is 1, so it's going to open up and it's going to hit x equals 2 and x equals 3, and that means the vertex is probably halfway between there. At x is probably at 2.5, and that's what our graph looks like. So let's see if we can apply the same kind of reasoning to this more complicated polynomial. And we're going to have to take one extra step on this one because it is unclear just by looking at the polynomial what the end behavior looks like. So let's actually first of all figure out what the end behavior is. We kind of figured that out back in the old days when we were looking at the end behavior of different kinds of polynomials. And the end behavior is completely determined by the leading term, which is the highest power of x. What's that leading term going to be? Well, it's going to have a 2 in there, right? Because when imagine all three of those terms, factors multiplied out, you're going to have a 2 in front of the leading term, and then the highest power of x is going to come when we get an x, an x, and an x. That's an x cubed, right? We have an x from each of the factors, x plus 2, x minus 1, and x minus 4. So that means that is going to be our leading term, which is exactly how our end behavior is going to be. So as x goes to infinity, that means f of x is going to go to infinity, right? Because x cubed is going to infinity. Multiply that by 2, still going to infinity. And as x goes to negative infinity, it's going to be a little bit different. Our x cubed is going to go to negative infinity because you're multiplying a hugely negative number by itself 3 times. Multiplying it by 2, still going to negative infinity. So if we want to know what that looks like on the graph, there's the part that's going to infinity, there's the part that's going to negative infinity. Right? And then now it's just our job to figure out what happens in between those. All right, yeah. Oh, yeah. Hey, that's the exact question. What happens in between? That's a good question. Wish I thought of that. All right, so the x-intercepts, well, let's see what the x-intercepts are. So if we set that equal to 0, that means one of those factors have to be 0. The 2 is certainly not going to be 0, so it has to be either x plus 2, x minus 1, or x minus 4, which gives us the values of x equals negative 2, 1, and 4 for our x-intercepts. So there's where our x-intercepts are. Now that we know what the leftmost and rightmost x-intercept is, we have an idea of what our end behavior part of our graph is going to look like. Right? They're going to start at the leftmost and rightmost x-intercept and then take off to whatever their appropriate infinity is. Positive infinity on the right, negative infinity on the left. Now we just got to figure out what happens in between. Well, in between negative 2 and 1, what's going to happen is we're going to have to go up and then down, moving in the same direction. And then between 1 and 4, we're going to keep moving in that direction, cutting right through. And then we get a graph looking like that. Alright, so now that you've seen the kind of analysis we do to figure out the graphs of these polynomials, now you're ready to work on the in-class activities. The name of the file that you're going to be looking for is called Graphing Polynomials from Roots.